175, Lesson 19, Section 5.5, Properties of Logarithms. And we're going to look at more with properties of logarithms. And so far we've looked at some established properties, such as log 1 of any base is equal to 0. And also we know that log a, base a, well a, this is implied that this is a to the first power. So a, log a, base a, these two bases are the same, so your answer is your exponent. So that would equal to 1. And so from there, y equals to log 1 base a, that's just going to be 0. If we were to change that to an exponential form, we can see that a to any power, a to the y would be 0. 0 with any base is still going to be 1. Anything to the 0 power is still going to be 1. So therefore y equals to 0 when we have a log 1. And so that just proves that log 1 base to any base is equal to 0. Here we converted from logarithm to exponential form. Here's our base for our logarithm. Here's our base for our exponent. The a moves to the other side. The y becomes the exponent for your base. And so that would have to be a to the first power. And so we see that y would have to equal 1. So therefore, when you have your base for your exponent, your base for your logarithm are the same, your answer is your exponent. In this case, it's 1. Well, this is illustrating that if you had, let's say, for example, log, let's say 5, base 5, and that's all, and you didn't have anything for an exponent, well, you know this has to be 5 to the first power, right? And so your answer there would be 1. So here we have our base for our logarithm, base for our exponent is the same. Our answer is our exponent. And so here we show these properties here. Log a base a is equal to 1. Alright, with this one, here we have a base, a, and then we have a log with the same base here. In this case, we have our base for our exponent is the same for our base for our logarithm, so therefore our answer is our logarithm, m. So in other words, if we had, let's say, 7, and then up here as an exponent we had log 5, and that's base 7. Well, our base for our exponent is the same for our base for our exponent, so our answer is our logarithm, and so that would be 5. Here, our logarithm base a is raised to a power equals to that power. So again, we've already mentioned this before. Log a, base a, our answer is, when these two bases are the same, our answer is our exponent. We know that already. We've worked with those already. Okay, properties 1 and 2. Here we have pi, log pi to the third power base pi. Our base for our logarithm and our base for our exponent are the same, so our answer is our exponent. Here we have 5, and then the log square root 3 base 5. All of this up here is an exponent. Okay, so in other words, this would be like 5 is an exponent, log square root 3 base 5. All of this is an exponent. So therefore, these two bases are the same, and since they are exponent and logarithm are inverses of each other, our answer is our logarithm. Okay, now natural log and e, they're inverses of each other, so this would be like log base e. This would be like log e to the 0.35t, and here we have the log base e and the base for our exponent are the same. So here in this case, the entire exponent 0.35t is the answer. So the answer is going to be 0.35t. Alright, properties of logarithms. When we have two terms that are multiplied together, we want to, sometimes when we're solving problems, we want to expand that so that we have a sum or difference of logarithms. In this case, it's the sum of logarithms. So when we're multiplying our logarithm, then we're going to add. So in other words, this is log m times n base a. So this would be log m base a plus log n base a. Because they're multiplying, you're going to add the two, and each one gets their own logarithm, and the bases will always be the same. Here we have log m divided by log n base a. Here they're dividing, so you're going to subtract. You're going to have a difference of logarithms. So this would be log m base a minus log n base a. And a way to remember that is anything that's in the denominator gets a minus. And then anything in the numerator, that's always going to be a plus. Alright, the logs of a power equals, so let's take a look at an example here. Let's say that we have log x, y over z, z and u base a. Well, this will be log x to the a power plus log y, oops, that's log, y base a power minus log z base a minus log u base a. So anything in the denominator will get a minus. Anything in the numerator will get a plus. That's one way to remember that. Okay, here, log m to the r power base a. We want to expand that. So the power will move out front. And so this will be r times log m base a. So anything with a power to it is going to get moved out front. Alright, and these are our properties of logarithms. Write a logarithmic expression as a sum or difference of logarithms. So first thing we want to do here is we want to move the powers out front. So we're going to, in this case, there's nothing that's encompassing the whole thing. So we're going to go ahead, so there's no power up here, there's nothing to move out front. So we're going to go ahead and these two, x squared and the square root, are multiplying, so we're going to expand those first. So this is x squared, since it's multiplying here, then this will be x squared base 2 plus this cube root of x minus 1 base 2. And that follows this property here of logarithms. Alright, now we change this cube root to 1/3. Because this root here, that would be like n, right? And so this would be 1 over n. Alright, now at this point, we want to move our powers out front and become factors. So this would be x, this would become 2 log x base 2. And then how about this 1/3 here? This moves out front and it'll be 1/3 times log, and then parentheses x minus 1 base 2. And that's it, because this is minus here. We can only add use sum or difference when we're multiplying. So this is not multiplying, So we can't do anything, and so we just leave it like that. And that's it. We've expanded that out. Okay, here we have, this is like m over n. So we are going to add or subtract these two. Which one will we do? You should have said we are going to subtract the numerator. So this will be log, and the numerator, base 6, minus log, denominator, base 6. Alright, and this is our difference property of logarithms. So this will be log x to the 4th, base 6, minus log x squared plus 3, close parentheses squared, base 6. Now are we done at this point? You should have said no. Well, what do we have to do now? You should have said we have to take our exponents and move them out front and become factors. So this will be 4 times log x base 6. Now how about this one? You should have said we're going to take the outside 2, move it out front. And so this would be 4 log x base 6 minus 2. This 2 moves out front, parentheses x squared plus 3 base 6. Now because this is plus, we can't do anything to this. So we're done with this, expanding this out. Cannot expand a plus or minus, only products or different or quotients like what we have here. And so this property of moving the r out front, that's what we did with these exponents. So even though this has an exponent here, because this is plus, we can't do anything with this inside. And so that's it. We've simplified that. We've expanded as far as we can to our difference of logarithms. Okay, here we have natural log. Well, natural log is the same way to expand the sum or difference like we would with logarithms. And only now we're just going to use natural log for each one. So because these are multiplying up here, we're going to add these two. Because this is a denominator down here, we're going to subtract. This will be a minus. Okay, so we're going to have natural log x cubed plus natural log the square root of x minus 2 minus natural log x plus 1 close parentheses squared for the first. Okay, now this one here, they just went ahead and subtracted, but you can do it all in one step. So now in this case, they just took the denominator and made it a minus. Now in this case here, because they're times, right, multiplying, you're going to apply a natural log x cubed plus natural log x minus 2, and then we change the radical to an exponent. In this case, it would be square root, the index is 2, so this would be 1/2. Minus, and then x plus 1, close parentheses squared. Now, I ask you, are we finished at this point? You should have said no. Well, what do we do now? You should have said we would take the exponent and we move it out front as factors. So the 3, that moves out front, so that would be 3 times natural log x. Now what about the next one? The 1/2 moves out front, becomes 1/2 times natural log x minus 2. And then the 2 here, this moves out front. So we always add or subtract first, and then we move the exponents out in front. Now because we have an x minus 2, cannot do anything. It's only when we're multiplying or dividing that we can expand from here. So the x minus 2 and the x plus 1 can't do any more to that. So that's expanded out in the sum and difference as far as we can go. Write a logarithmic expression as a single logarithm. So what we're going to do here is condense these. So at this point, what we want to do is we're going to take the exponents first, and we're going to, the number times the logarithm, and we're going to move them up as exponents. And so in this case, this will become natural log 2 cubed plus natural log x squared. Now we can go ahead and change that 2 cubed to an 8. And so this would be natural log 8 plus natural log x squared. And now because we're adding, right, that's like natural log AB equals to natural log A plus natural log B. Only now we're going back the other way. So in this case, this would be natural log 8x squared. And we've condensed that. And so that's what we've done here. The 3 moves up front and becomes, we can change that to an 8, and then it becomes x squared. Alright, the next one. First thing we do is we always move the exponents up front. Okay, and so in this case, this is going to become log 4 to the 1/2 power minus log, and then the 2, that moves up front, and this is base A. And this becomes 5 squared. Well, that's going to be the same thing as saying the square root. Log square root of 4 base A minus log 25. 5 squared is 25, base A. Well, square root of 4 is 2. So this would be log 2. And because it's minus, it's going to follow the property of log A over B equals to log A minus log B. So this will become 2 over 25, base A. And so that's what we get. The 1/2 moves up front, and then becomes the square root of 4. Alright, and so let's see what happens with this next one. In this case, anything that's a negative is going to go in the denominator. And so anything that's a plus is going to go in the numerator. So in this case, now they showed it as a negative exponent, but you can take this 2 and leave the negative there. And so this would be a minus log 3 squared, and then this is going to be plus log, and this is base A. Log 2, and then this 3 moves up as an exponent, cubed base A, minus, and then nothing happens. There's no exponent here, so we just leave it. X squared plus 1, base A. So now this will all become a single logarithm base A. Now anything that has a minus is going to go in the denominator. Anything that has a plus is going to be going in the numerator. So this will be log 2 to the 3rd power. That goes in the numerator. And so that's going to become an 8. Now here, this has a denominator, so this will be 3 squared. That moves down into the denominator. And then here, this has a minus, so that will also move down into the denominator, x squared plus 1. Okay, and so now this will all be just log with the base A, and this will be 2 cubed is 8 over 3 squared is 9, and then this will be x squared plus 1 in parentheses like that, and you can just leave it like that, and that's your answer. Alright, and so basically that's what we get here. Alright, now here they made it 3 to negative 2, and then they moved it down, but I tend to prefer the other method. Okay, so we have m equals n. If m equals n, then log m base A equals to log n base A. If log m base A equals to log n base A, then m equals n. So in other words, if we have something like this, log x base 2 equals to log 5 base 2. Well, the bases here are the same. So in that case, then x equals to 5. You take your two logs and set them equal to each other. So that was similar to when we had our exponents. A to the u equals to a to the v. Then you set your exponents equal to each other. So this is basically the same type of property. Alright, evaluate logarithms whose base is neither 10 nor e. So we said before that log x is the same thing as log x base 10, and that is something that the calculator can use. Your calculator is base 10, and you can also use natural log as well. Log x base e, we also know that's natural log x. Okay, so here we want to use the change of base. We want to use approximate logarithm whose base is neither 10 nor e. So we can't use the calculator. So what we have to do here is we have to go ahead and we can go ahead and change this. Well, let's see, we don't know what 3 to some power is going to give us 12 as exponential form. So what we do is from here we can go ahead and apply the natural log to both sides. So when we do that, what we get here is now this y can move out front like that, and now we divide natural log 12 over natural log 3, and from here we can go ahead and use the change of base formula. And so the change of base formula, the change of base formula is log x base a equals to log x base 10 over log a base 10. So whatever your base is going to be the log for your denominator. Or you could also use natural log x over natural log a. Either one. In this case, they use natural log, but you could have just as easily have just put log base 10 and log base 10 here, and you would get the same answer. Okay, and so that's what this is here, the change of base formula. So in this case, the base b, would be either base 10 or base e, which is natural log, and those are the only two that you can use on the calculator. Okay, and here this is base 10, log m base 10, log a base 10, or the natural log m over natural log a. And that's our approximate. Okay, so here we're going to use the change of base formula, and so this will be, in this first one here, this will be, you should have said, if we're looking at log 89 base 5. Well, our calculator does not have base 5. It only has base 10, or base, natural log, base e. So we have to change this to log 89 base 10 over log 5 base 10. And now you can use that in your calculator. So use the log button on your calculator for that. Alright, and so for the first one here, where they use log, see here they use log or natural log, the numbers start off different, but in the end the answers are the same. Okay, well let's look at B. Here, this would be log square root 5 over log square root 2. And they took the 1/2s out, but in the calculator you could just use the square root of 5. And so we get 2.3219. And so in using whether it's log or natural log, you can change log square root of 5 over square root of 2, and you can use natural log instead of just log. and you get the same answer. 2.3219, 2.3219. And that's our summary, our properties of logarithms.